Welcome to qnawire.
We want to calculate the energy storage of the capacitor. It is related to the capacitance of the capacitor by equation in the form of U is equal to 1 half K C0 V square. Let's mention is as equation 1, where the potential difference equals ED, where E represents 50% of the dielectric strength of each material. So equation 1 will be in the form of U is equal to 1 half K C0 ED square. Let's say equation number 2, where the term Kc0 represents the capacitance after the dielectric material is inserted. Now let us plug our values for K and E for each material in table to get U of each material, where E is equal to 0.50 times EM. For polycarbonate, K is equal to 2.8 and EM is equal to 3 into 10 to power 7 volt per meter. Now let's calculate the U. So to calculate this one, we are going to use the second formula, this one. So according to, we can write 1 half K, which is 2.8 into C0, which is 6.0 into 10 to power minus 12 farad into 0.50 times EM, which is 3 into 10 to power 7 volt per meter, and D. So D is 0.0025 meter whole square. Here, let's also remember E is equal to 0.50 times EM. Okay, coming back to the energy again. So we will get here U as 11.81 into 10 to power minus 3 joule. Now, when polyester has the K value 3.3 and EM value is 6 into 10 to power 7 volt per meter, so in this case, the energy U can be calculated with the formula 2, which is 1 half into K. Now the K is 3.3 into C0, which is 6 into 10 to power minus 12 farad into 0.50 into EM, which is 6 into 10 to power 7 into D, which is 0025 meter whole square. So in this case, we will get U is equal to 55.68 into 10 to power minus 3 joule. Now, in the second case, whenever polypropylene is having K is equal to 2.2 and EM is equal to 7 into 10 to power 7 volt per meter. So in that case, again we are going to use the same formula for the U, and we can write 1 half K is 2.2, C0 is 6 into 10 to power minus 12 into 0.50 into EM is 7 into 10 to power 7 volt per meter into D is 0.0025 whole square. So U will be 50.53 into 10 to power minus 3 joule. In the case of polystyrene, K is equal to 2.6 and EM is equal to 2 into 10 to power 7 volt per meter. So again with the same method, by using the second formula, we can calculate the energy as U is equal to 1 half K0 into zero point 0.5 EMD whole square. So using this formula, we can write U is equal to 4.87 into 10 to power minus 3 joule. Now, in case of Pyrex, K is equal to 4.7 and EM is equal to 1 into 10 to power 7 volt per meter. So again using the second number formula of U, we can calculate as 1 half K C0 0.5 EMD whole square is equal to, we will get 2.20 into 10 to power minus 3 joule. As shown by the results, polyester has the maximum energy and will be suitable for the first application. Now moving toward the second part, the storage charge in the capacitor is related to the energy storage in the form of Q is equal to 2K C0 U. Let's say equation number 3. Now let's plug our values for K and U into equation 3 for each material to get the storage charges. So for the polycarbonate, K is equal to 2.8 and U is equal to 11.81 into 10 to power minus 3 joule. So Using this formula and by putting all the values, we can calculate Q is equivalent to 0.39 picocoulomb. Now for the polyester, K is equal to 3.3, U is equal to 55.68 into 10 to power minus 3 joule. So Q will be equivalent to 2.2 picocoulomb. This we can calculate using equation number 3. Now for the polypropylene, K is equal to 2.2 and U is equal to 50.53 into 10 to power minus 3 joule. So Q will be equivalent to 1.33 picocoulomb. For polystyrene, K is equal to 2.6, U is equal to 4.87 into 10 to power minus 3 joule. So Q will be equivalent to 0.15 picocoulomb. Now for pyrex, K is equal to 4.7 and U is equal to 2.20 into 10 to power minus 3 joule. So Q is equivalent to 0.12 picocoulomb. As shown by the result, polyester has the maximum charge and will be suitable for the second application. Now, in part 3, the potential difference across the capacitor depends on the electric field between the two plates and it is given by V is equal to ED is equal to 0.5 EM into D, because E is equal to zero point 0.5 times EM. Let's say this equation number 4. Now we can plug our values for D and EM into equation 4 for each material to get V. So first we will start with the polycarbonate. So polycarbonate, we can calculate V as zero point 0.5, E is 3 into 10 to power 7 volt per meter and D is 0.0025 meter. So V will be 37,500 volt. Similarly, we can calculate for the polyester. So for the polyester, V is equivalent to 75,000 volt. For the polypropylene, V is equal to 87,500 volt. For the polystyrene, V is equal to 25,000 volt. And for the Pyrex, V is equal to 12,500 volt. In the last part, as shown by the results, polyester is the best choice for the maximum energy and the maximum charge, but the best choice for the maximum electric field is polypropylene.